Be a quick raw video on how we're gonna hopefully hook up our ultrasonic sensors for the robotics competition coming up soon. I want to make it easy. I am working with 5th graders, and so I want to make it easy for them to plug it in, and I don't want to, there's some really good examples online if you want more details, but I wanted to make it really simple. So I'm actually we're using the Pi Servo HAT board, and so I'm gonna use my custom space up in here, allow you to do whatever you want to do to wire it up. And the point of it is so we have an ultrasonic sensor here to measure distance. So I'm going to see how far away this glass of water is. And according to this, it is 5.1 centimeters. Quick shot of the code. I just downloaded some code on the internet here. 2 things that you'll need to know when you're running the code, but that's not really what this tutorial is about, is you run on the GPI set mode to the board. You don't have to run board, but I'm running this on the trigger is going to be on 40 and the echo is going to be on 38. Let's see. Yep, trigger and echo. So these are the things that you might want to pay attention to, because we're going to hard wire them. And so 38 actually means 20 on the hat board, and 40 means 21 on the hat board. Actually, yeah, that's right. And I'm going to try to get a little better example. Now, you'll see a lot of things about voltage dividers and stuff on the internet. Don't worry about that if we're just wiring this up, because I'm going to give you some numbers, and if you don't like these capacitors that we're going to wire up, if you don't like or resistors, sorry, if you don't like the resistors that we're going to use, you can use whatever numbers they tell you to use on the internet. There's a whole bunch of different ones. I think I'm using a 680 and a 1K, and but I'll confirm that when I go over and we start soldering this puppy up. But I tried to make it as simple as possible so that I could just have 4 plugs. Ran out of cable here, so I can just plug 1, 2, 3, 4. 2 are for power, so positive and negative, and 1 is for output and 1's for input of our distance sensor. And so I'll show you, it's kind of fun. So you can see I'm moving the glass farther away, and now it's saying it's 13 centimeters. So that's really what we're going to be doing. I'm going to pause it and go over to the soldering station now. What we're trying to get to, red and black, obviously, positive and negative, or ground and positive, and apologize for the 2 yellow wires. This one here is going to go to the trigger. Let's see if it'll, yep, yellow is going to the trigger. And this yellow one here is looping over and going to green, which is going to go to our echo. You could also think of it as input and output. It should be clearly labeled on the HCSR04. The reason why you have to do this, just real quick, is you got 5 volts. Too much for the Raspberry Pi. We want to get the voltage down so we don't burn out our Pi. And as you can see, I've got a stack of 1K resistors and some 680 resistors. So 1,680, and what that's going to do is help. We're going to put 1 on one side and 1 on the other, and it's going to help us regulate our voltage so we don't blow up the Raspberry Pi. And I'm doing it on the hat board, so there's one less thing we have to lose come competition day. And so I'm going to take you through step by step how to go from here to here. Okay, with your hat board, you should have got, you probably don't have a rail that looks like this, but you should have gotten some sort of pieces that went with it. I don't have those. I'm just going to snap these off, and I'm going to snap one of them off, and we'll just solder one of them on. We'll do this piece one at a time so you can see where it all goes. And you should be able to look at any diagram after we're done on the internet with the Raspberry Pi and the ultrasonic sensor and follow it. But this is how I'm hooking it onto this particular board. Okay, I took my pliers here and just snipped off one of these. And you could use anything. You probably have to test it in the wires, but you could even take a paper clip probably and cut it. Or if you have, a breadboard and the pieces with the breadboard, you could just take these and cut them. Anything. I mean, it's nice that it has the little piece of plastic there to help as a riser. But now I'm going to show you where we're going to put the first one. Kind of hard doing this one-handed. So what I did is I stuck it through a piece of tape here. And I want the short end sticking out, and I'm using the tape to hold it to the breadboard so when I flip it over and solder it, it won't come out. But we want the short end going. Just for doing this one-handed, but we're going to solder into the last hole right here. You'll be on the right one, you can't see it, but see those numbers on the side? It'll say 21, which means GPIO 21. And what that really means, I'm trying not to get into a lot of theory on this, but you've got 40 pins on the Raspberry Pi, but only 20-something of them do anything. The rest of them are just hookups for power and other protocols that you're probably not going to be using. And so the GPIO library deals with things that you're going to actually be using. So they probably should have just, if I was the HAT people, I probably would have just done the physical board numbers on here. But anyway, I'm going to solder that piece on there. I have a piece of tape to hold it in place if I haven't said that already. My phone ran out of space, so I had to stop and delete some stuff. So let me solder that up real quick. Okay, the first one's soldered. You probably can't see it too well. I'm just using a regular soldering iron, and I've got this really fine solder spool that I've had for, golly, who knows. And but it's some really fine stuff, so I'm gonna do that. So now I'll get the second one set up to show you what the second one is. Okay, the next one we're doing here is the 5-volt. Again, sorry for the shakiness of it. Let me get a pencil. So we want to hook up on this 5-volt rail right here. Just for fun, I'm going to hook it up at the end down here. So I'm going to tape it up and push it in. I could do ground at the same time, which the ground is the third one right here. So all these are actually the same thing. They're all connected. If you flip it over and you look, kind of tough to see with this, but you can see these are just circles and they're not connected. But every one of them on this, the whole rail all the way across is the same. So it doesn't matter if you do a sloppy solder job across these. Well, sloppy this way. You don't want to do sloppy this way. You don't want your ground and your 3-volt and your 5-volt to hook up. But again, we're going to hook up on the 5-volt and the ground. Okay, I decided to turn the light on, shine a little bit more light. I did the 5-volt one first, and then I did the ground. I figured my chances of getting them straight were much better. So that's what it looks like now. My first one that I soldered in was a little crooked. Maybe I'll heat that up later and straighten it out. But so that's kind of what it looks like now. And now we'll start getting stuff ready for wiring the resistors. Again, I apologize for the shakiness of this and how raw it is in a one shot, but I'm going to start with my 1K, and you can see I bent it in half, and I am going to drop it in the second row. Let's see if I can do this. Blindfold, or man, it's tough working through a camera. What I want to do is I want to drop it in the second hole here. I can't do it, so I'll just point to it. But what I'm trying to get to is I want to drop it one side in this second hole right there, and one side into ground, because the 1K touches up against the ground. So that's the first thing that I'm going to do. Let's drop it in there. I'll drop it in, solder it, show you what it looks like. Okay, I've got that one soldered in. You can see that it's one in, so come one layer in, and I've got it hooked to the ground and to the other, to just a free open circle. Now, I didn't use tape on this. It's already bent, so all I had to do was just push the wires through and bend them. See if I can get it to focus a little bit better. That's what it looks like from the top. I could try to optimize this and use less holes, but I'm trying to make this pretty simple. So now I'm going to hook up my wire that's going to go to pin number 20. So we're going to just make a thing that's going to go from right here to number 20, and then we're going to put our other resistor on the other side of it. Okay, last time I did this, I did the wire on the top, but I just have a insulated wire, so I'm going from 20 over here, over to right next to the resistor we just wired in, and I want to wrap this wire around it because I want them to connect. I want to connect those two, and I could solder it, but I'm just going to wrap this wire around it a couple of times, so when I solder it'll come together. So I'm going to wrap that wire around, then I'm going to pause the video, and I'm going to solder over here and over here. I'm probably going to solder them from the top. When I first did it, I didn't want to do it this way because the wires were sticking up, and I thought the kids might think that's a pin and they might try to plug it in, and I don't want anyone connecting anything to that, so I'm going to just snip those off. I might solder them from the top, but I'm going to snip them off. So let me do that, and then I'll turn the camera back on. Okay, so it's important this side doesn't touch anything. This side is connected to the purple wire. I wrapped it around a couple times, soldered the wire on there, made sure it was soldered. Did a quick solder over here. You can see the black that I got on the purple. And let's try to flip it over and take a look. And so you can kind of see, so there's the old rail sticking up. Got a little bit too much solder on there, but it doesn't appear to be bleeding over, so it doesn't matter. And then I also did a quick touch on number 20. And now that pin is sticking up. The other one, well, I want to keep my 21 pin sticking up on 20. You can't see it, but there's sticking up a little bit. Yeah, you can kind of see it now, right below the thing. So I'm going to snip that off, and I'm going to snip off all the other resistor wires, and then we'll go from there. Yeah, I'm going to clean those up. Okay, now I'm going to do more of the same. I've got my 680 resistor, and I'm going to put one side through here and the other side right next to it, and hook that up just like we did some of the other ones. And then I'll put another pin in, but I'll go through that. So I'm going to solder these up, or solder this one resistor up, and then I'll show the next part. Okay, I apologize for this. I know this is hard to see, but where's my? There we go. So had the wire coming in. I wrapped this side of the resistor around, soldered it on. I didn't solder this. I could have, just to help stabilize it. Probably will go back and do that. Then I soldered the other side. Really simple. We're just soldering up the resistor like we did before. You can hear the kids coming in from playing. So now we actually have two resistors. There's one. There's the purple wire that's sticking up. There's one side of the resistor that's going through the board. You can see I hadn't soldered that. Other resistor soldered on. Now we're going to put one more of these pins on the end right here. We're going to wrap this wire that's coming around that pin to connect it. And so and then we'll be all done. So then we can hook our when we hook up our ultrasonic sensor, we're going to plug in one thing on this post, one thing on this post, one thing on this post, and then one thing on this post all the way over here. I should probably make it more linear and make the post over on this one, or actually I could use it on this side. I think I'll do that this time. I'm going to put the post there. That way all the posts are all in an alignment there. The other one that I did them all on all the resistor work on the second rail, but I think I'm going to put the post right there so all 4 of those posts are aligned up with one another. Okay, so here it is. This is what it looks like. I should have grabbed my pencil before I turned it on. But, so the resistor that was coming out of there, I just I taped the pin in like I did before, and then I just did a half loop around it and soldered it in. If I would have realized that I was going to go sideways this time, I probably would have bent the resistor wire sideways so it didn't get so close to my other free port there. I turned the flash off because I think I got a little bit better picture. Not that you can see very well without it, or with it anyway. But that's it. Now I'm going to just clip these the resistor ends off, and pretty confident it'll work because the other one worked, and it's a pretty simple wire up. You could shorten this up and reuse some of the same holes. Probably do it a little cleaner than what I've done it. Set the bar pretty low for you. Here, I'll flip it over. Okay, I am going to turn the flash on, or try to. I think this side it does a little bit better. So you can see the resistors right by one another. Since I got a lot of solder on that post between the 2 resistors, I couldn't cut it down as close as I wanted to, but you won't be able to hook anything to it. So, but that's what it's going to look like, and then you can just follow the tutorials and figure out what your trigger, follow your triggers and your echo and power up based on some of the other tutorials. But hopefully this gives a fairly step-by-step detailed way of hooking up the servo hat to an ultrasonic sensor. And if you're not familiar with resistors, they're not directional. You can put them on either way. It doesn't matter. And if you don't know, they have colored bands around them so you can tell which one is which. This camera, I don't think you can see the bands well enough to see what's really going on, and my focus can't get close enough to see it anyway. But yeah, so it doesn't matter if you put them on backwards. Well, it matters which one, but I mean the direction. If this one has to go here and this one has to go here, but if I were to have the part that's on the bottom on the top, or the top part that's on the bottom, it doesn't matter. That's the part that doesn't matter. And then that should give us a little protection against touching anything on the Raspberry Pi below, but you should have a some kind of a shield on the top, or not shield, even some tape. If you put some tape over the bottom of this whole thing when you're all done, some electrical tape, so you don't touch any metal parts on the Raspberry Pi. And this will work without power. First, when I was debugging this, I was running it and it wasn't working, and I thought it wasn't because I had power, so I went and wired up the power to it. And it was just because I had the GPIO pins in the software backwards. I had the echo as the trigger and the trigger as the echo. I was able to fix that. So there you go.